Hi, it's Mr. Benson here with a video introducing the next topic, and it's our last topic for the year, and this is linear graphs. This is chapter 7 out of the new textbook. I'll put the PDF version of the chapter up on Compass. What I'd like you to do is actually read through the notes on each section in addition to watching my video. Look, it's a page or two each time, so you're really not looking at a lot of reading, but it just is another way of you looking at that information. So starting off with some basics, so things that hopefully you've done before, some things that we've definitely done in the previous topic on equations, and after you've watched this video you should be right to do the Are You Ready questions, and I'd like you to do all of those. So firstly, what's a linear graph? So linear graphs are graphs of linear equations. Now we've done a whole topic of those, so hopefully you know what I mean by that. So linear equations are ones with x to the power of 1. Now there are two forms that you'll see them in a lot of the time. They are this form here where we have y equals 2x plus 3. So we've got y on one side of the equal sign and x on the other side. That's one form. Another form you'll see sometimes is the x and y are on the same side, but you see that it's x not to the power of 2 or anything weird like that, and the same with y. And the other thing with these equations is they can both be written where the x and the y are both on the top line of the equation, in the numerator of the equation. So linear equations aren't weird stuff like x squared or 1 over x or sine of x or anything like that. Now the important thing about linear graphs is that they form straight lines, so the linear part is meaning that they are a straight line. Now one thing that you need to be able to do in this topic is representing coordinates on a Cartesian plane. So when we're drawing a graph, we have our Cartesian plane here, and you need to remember that we have our two axes, and we call the vertical one the y-axis and the horizontal one we call the x-axis. They are always that way around. If you get them mixed up, it will make everything else go horribly wrong. Now in the middle here, this point is where the values of x and y are both 0. So at this point here, it is well, we call it 0, 0, and I'll explain that a little bit better in a moment. And the other name for that is the origin. Now, when we're talking about x, y coordinates, we always have the x value first, so that is telling you where your point is located along this x-axis, so moving from left to right. And the y value second. The y value tells you where you are up and down. So we're going to have a go at plotting some points in a moment. Now one thing about your about how we're going to display this is you need to have a linear scale as well. So I'm going to run out of, no actually I won't run out of room on this if I keep my numbers pretty small. I'm just going to make it that each of these squares is 1. So going from here to here would be 1 on my x-axis, 2 on my x-axis, 3 on my x-axis, like that. Now going down here we're into negative numbers, so it would be -1, -2 and -3. Now the same on the y-axis, going up is increasing, so we have 1, 2 and 3, and likewise -1, -2 and -3 down here. Now let's plot some points on our Cartesian plane. Now starting off with the one that I've written up here, 2, 3. Now remember, the first value is the x, the second value is the y. So the first thing we've got to do is find out where 2 is on our x-axis. So 2 is here. So I'm going to start off at this point here. Now then I've got to think about where 3 is on the y-axis. So I'm going to move up 3. And this point is here. And I can label that, although you don't really need to. But just to be very clear that that is 2, 3. Now, look, let's just pick some other ones. We could do something like 2, 0. Now, whenever you see a 0, it's telling you that your point is on one of the axes. So in this case, when the y value is 0, so the y values are on the vertical axis, when the y value is 0, it's telling us that our point is somewhere on this axis, on the horizontal or x-axis. When the x value is 0, it's going to tell you that our point is somewhere up the vertical y-axis. So 2, 0, I go across the 2 on the x-axis. Now 0, I don't need to go anywhere up or down, so that point is here. And we'll just pick one last one. Let's do -2, -3. So it's kind of the opposite of the one we did first. So my x value of -2, I go across to -2 on the x-axis, then I go down to -3 on the y-axis, and my last point is here. Okay, moving on. We need to be able to calculate values, so tables of values of the y value of an equation corresponding to the x value, and sometimes you'll do the opposite way, but this is the most common form of it. Now, all you're really having to do here is substitute some numbers into an equation and then calculate the answer. In our tables we generally have the x values. Now the x values in a relation are called the domain, and the y values are called the range. Now those terms aren't very important at this stage, but later on in maths you'll come across them more often. Okay, now I'm actually going to start in the middle here because the numbers are slightly easier to work with, but it actually doesn't matter. Remember, you can use your calculator as well. But the reason I'm going to start in the middle is you'll see that some of the calculations are slightly easier, and you'll also see that there's a pattern in these. Now, one thing that's quite useful is that your x values should all be equally different from each other. It's a terrible way of saying that, but they're all different by 1 in this case. They could be all different by 2 or whatever. It doesn't really matter too much, but 1 is good. Okay, so I'm going to start here when x equals 0. So y is going to equal 2 times 0 plus 3. Now 2 times 0 is 0, so y is just going to equal 3 in this case. Now when I do the calculation over here, now I'm not going to write this one down, y equals 2 times 1 plus 3. Well, 2 ones are 2, plus 3 is 5. Going across to here, when x is 2, y is 2 times 2, and that's 4, plus 3 is 7. Now, you can see here that these are all differing from each other by a value of 2. Now, that's something important that we'll come back to later on in terms of where that number comes from and what it means. But one shortcut we can now take is that, well, if 5 is 2 less than 7, 3 is 2 less than 5, then my number over here would be 2 less than 3, which would be 1. And my number over here would be 2 less than that, which would be negative 1. You can always do that. As long as you've figured out how much difference there is between the two numbers that are next to each other, you can use this shortcut. If you are not completely confident that that's right, we can check as well. So let's just check this first value. Y equals 2 times minus 2 plus 3. You've got to be careful with your directed numbers when you're doing this. So 2 times minus 2 is minus 4 plus 3. That is minus 1. So the pattern works.